Hi, this is a video about an algorithm for ranking things. So in my line of business, sometimes there will be committees that have to rank things. Maybe it's scholarships or something like that. And I'm going to propose a method which works if there is an odd number of people voting, number one, and number two, if each individual who's ranking does not have any ties. If they have ties, this doesn't work. If there's an even number of people, what you can do is designate someone as having more power, maybe the uh, the chair of the committee or something like that, and let them vote twice, and then the even number turns into an odd number. I want to imagine some data here, and the data are being defined in these lines. I'm showing you, by the way, a text editor looking at our code, and the algorithm that I'm talking about here is written in our code. It could be written in different codes as well. Okay, and I think that this is not kind of in Excel or whatever, so it does require a little bit of coding or just using some code. So the code is in a function which I call ranker, and defined in line 2, etc. And so it's a function called ranker. That's what this code means. And it has a bunch of arguments. It has one argument, which I'm calling names. That'll be the names of the individuals. If it's people being ranked or if it's whatever proposals being ranked, whatever it is. Dot, dot, dot means there can be more arguments. And these will be columns of rankings. Let's say, just for concreteness, that 1 means the best and that n means the worst. So it would be numbers between 1 and n with no duplicates. And debug is a flag that will allow for some printing. I'm going to walk through this code in detail, but you see it's going from line 2 to line 68. So it's not especially long. It could be a heck of a lot shorter, honestly. I've written it in such a way as to be sort of self-explanatory. But the other thing is that quite a lot of it, let's see, we're about here. Much of that is just checking for bad conditions. Like if the names are not unique, it's going to make an error message saying that's no good. If you didn't give it any rankings, it's going to say you got to give it rankings. If some, I don't think this can happen. Well, could happen. Yeah, sure, that could happen. If the rankings are not of equal length, it's going to complain about that. If there isn't one ranking for each person, it's going to complain about that. Here it's complaining about if you don't have an odd number of rankers and etc. So anyway, a lot of it is just checking. Maybe it's typical of code that maybe a quarter of the code is checking. And the guts of the code is here. I'm doing this too quickly for you to understand it, but I have some little logging things and exchanges, how many exchanges we did. I'm going to explain what I mean by an exchange in a minute. Right. So I'm calling these eras or steps or something like that. And it will do at most n minus 1. N is the number of people or whatever, number of things being ranked, rankees, I guess I could say. Okay, and each era, what it's going to do is it's going to go through from 1 to n minus 1. And it's going to be using a bubble sort. Now, if you are familiar with sorting, you'll realize that I'm doing more work than I have to in this, but it doesn't really matter. Like I'm doing at most, twice as much work, I guess, as I should be doing, because I don't have to rank things that are already ranked. I could explain that in just a moment, but I don't care because you're probably only ranking maybe a few hundred. It's unlikely you're ranking a million things, and even with a million, your computer's fast enough to do that effectively instantaneously. Now, I don't really want to go through it, but the guts here is in these 3 lines, these 3 lines right here. What that's doing is it's exchanging things. It's saying, flip these 2 things, flip I and I plus 1. Okay, so, and then I do some cleanup at the end, and there's a lot of debugging all the way through. So debugging all the way through as well. So that's what that does. I want to just do a test case here. This could be a sample data set. So the first column, okay, and I'm putting it in quotes, so you could just read it in from a file, but I didn't want to do that here, but it would be typical to read it from a file. So name that column will be items being ranked. This would be ranked from committee number 1, R1, R2 for committee number 2, etc. So you'll notice that each of these numbers are going from 1 to 5. There are no duplicates in there, and they've ranked all of them. So it satisfies the conditions that are required. What I do here is I read the data, and here, and you read it from a file probably, but here I've got the data straight in this thing, but straight in the code, I mean. Then I call this ranker function to rank them. And again, the parameters of the function are the names of the things being ranked, the scores from each of the odd number of committee members. Okay, so that will actually give the ranking that I think makes sense, but I'm going to show another ranking that sometimes people do, which is you take the sum of all the scores and you rank by that. When I do order of order, what it's doing is it's ranking. And so I'm shoving that in as well. Okay, so I'm going to run the code. So I just ran the code, and it took no time, right? And so basically what it's done here is it's put them in the order that number C was the best, the highest ranked, number E was second, D and A and B followed that. That's the rank according to the scheme, which I kind of prefer and which I'll be explaining now in a little bit more detail. But I also made a score, which is just the sum, like in this case for E, that would be 9. It would be the sum of 2 and 5 and 2. 9 for E. Where are we at? Here's 9 for E. Notice that there's, right, and so that's what I do. And then I ranked by that. Rank new is basically ranking. Well, goodness, there's a problem here, isn't there? That two people have the same score. And the more people, I'm saying the word people, but two of the things being evaluated have the same score. And the larger is the number of people being evaluated, I think the more likely it is that you'll have some duplicates. And then, well, what do you do? And now I'm going to explain to you the method. And I'll do it by let's see. Okay, so what I've done is I've just copied the data. I'm just cleaning it up a little bit here. I don't know why I care about this, but I'm weird that way. Okay, I've just kind of cleaned it up. Now, here's what I'm going to do. I'm going to start at the top, and what I want is I want the top person. I'll just say person from now on, okay? I want the top person to be at the top of the list, and I'm going to do a bubble sort. What I'm going to do is I'm going to go through all of these. There's 5 of them. I'm going to go through all 5, and I'm going to arrange that the one that should be on the bottom will be on the bottom. Okay, the lowest, the person who's least eligible for the scholarship or the proposal that is least like worthy of being funded, etc., would be on the bottom. And so that will take what I'll call an era to do that. And after that, I know that the worst one is on the bottom, and then I only have to do something to the 4 remaining. And after that, the 3 and then the 2. Okay. Now, here's the deal. This algorithm, what I'm going to do is, I think it adheres best to the opinion of the committee members. And imagine that you're in a room and you simply ask the people in the room, considering candidate A and B, can I have hands for who thinks that A should be ranked higher than B? Let me count them. This person says higher. This person says higher. This person says higher. Therefore, I'm not going to do anything. Now I'm going to look at B and C. And again, I'm asking all the people, which is higher? Well, this one says that B should go below C, and this one says it should go below C, and that says it should go below C. So let me just do that, and I'll clean up. Now I'm going to consider between B and D. This person says B should go below D, and all 3 of them say that. And now we'll consider just these 2. And this committee member says this B should go down. This says B should stay, and this says should go down. So at the end of this, we've decided on this one. We've decided that B should be the bottom. Look down at the bottom here, and you can see that's what my algorithm gave. It said that B should go on the bottom. But now we'll continue with the algorithm, just so you understand how it works. And again, it's called a bubble sort. Now I'm comparing A and C, and I'm asking the question, is A better than C? That person says no, this person says yes, this person says no. That means I have to exchange them. Now I'm looking between A and D, and the question is, should A be shoved down below D? And this person says nope, and this person says yep, and this person says yep. And again, that was a no and a yes and a yes, so it had to go down. And now we're comparing D and A and E. Go down, that person says stay, go down. So we had to move it down. And at this stage, we know that A is in the correct location. We have to do the same procedure with these guys. And we're going to be comparing C and D. So this person says keep C where it is. This person says move it down. This says keep it where it is. So that's fine. So we don't have to do anything. And now I'm comparing A and D. This person says move D down. This person says keep it where it is. And this person says move it down. At this stage, we've done it also for for D, so I have to consider that anymore. So now all we're doing is we have to consider these two. And so the question is, should C move down? This person says no, this person says no, this person says no. Therefore, C is in the right location, and therefore A must be in the right location as well. So let's have a look down. We should be getting C, E, D, A, B, C, E, D, A, B. So that's how it works. It's bubble sorting. And again, the way this worked, if there's an odd number of committee members, then when you tally up the yeses and nos, there's always an answer. There's always either more yeses than nos or more nos than yes. There's an odd number of people in the committee. That's how that works. And also, you can't have any equal rankings. Most committees have that rule anyway. They tell people you can't come to the meeting saying that you have equal rankings. Your job is to rank them. Suck it up and do your job. Okay, so that's how the technique works. And again, going down to here, the score thing, which I've also added in this line. That's just the sum. Let's just check that. Is 5 the sum of 1 plus 3 plus 1? Yep. Let's go for number. This one, 4, that's 8. Okay, so we've done that correctly. And then is this ranking, so is 5 the smallest? Yeah, it is. And is 2 the next? Yeah, well, then we get 9, which is a repeated score. That's the flaw of doing this scheme where you just add up the rankings. You're going to have these. And so that's basically why the answers come out different. But they're really quite different, aren't they? There's an agreement on which is number 1. We disagree on which is number 2. We disagree on which is number 3. We disagree on which is number 4. We do agree on which is number 5. So I guess we have 2 out of 5 agreements, but that ain't good. I can make this code available to anyone who wants it. Thanks for watching. If you watched it this far, I know it's kind of boring to watch someone talk about code, but I've had to explain this to quite a few people over the years. And I figured I may as well just make a video and put it on YouTube where people can get it. Thanks for watching. Take care. Bye.